Come on, man. Just do it. Just do it. Come on, man. Just do it. Come on.
Now,
Come on. Come
now,
on. Come on.
now,
Come
not gonna do it. Not gonna do it.
What are you not gonna do?
on. Put his hair to use.
Oh, you want him to flip his bangs.
I want him to go like
Oh,
this.
okay, okay, okay.
As a black man who can't do that naturally, I have to live
Oh,
vicariously through it.
Live
But
vicariously through my hair.
yeah.
uh,
Congrats, we're live. All right. Well, welcome anyone who is watching us on the grand internet. Today is November 13th, and here's show and tell. Go for whoever's first.
yeah. So I'm first. Um, and maybe. Hey, what up, Andrew? I'm trying to. Apologies to our listeners. I'm trying to pull up the YouTube chat so that I can just be paying attention to what's in the chat in case any questions come through. And also, I'm trying to do a soft delay for Brian because I want Brian to be here for my show and tell. I say my show and tell, but it's really our show and tell. And R means Ryan Messner. R stands for Ryan Messner in this case. So let me. I'm almost there. Delay. Trying to get to the chat. Okay. Open chat in new window. Pop out chat. All right, I'm all set up. I'm ready to go. Sorry about the delay. So last week, Brian Dunn said, and I quote, "Does Julia do any GPU programming?" And I said, "Well, I'll do some research and I'll get back to you next week." So it's next week right now. And here's what I've learned. I've learned that I do not have a supported GPU, but Ryan Messner does. Ryan Messner has a NVIDIA GTX 1070 Ti. We don't know what the Ti stands for. I think, as far as we can tell, Ti stands for better. Um, so yeah, when Ryan shares his screen, we're gonna launch into some Julia GPU programming. Yes. Okay. So our demonstration is going to be sort of underwhelming. We're going to take an array of size 2 to the 20th, and we're going to add that to another array of size 2 to the 20th. So first we got to set up our arrays probably. So Ryan is just going through our history here. This is going to be a little bit messy because like all of this is in our history, but it's not really like easy to sort of put together. But what Ryan did just there is he filled up an array of 2 to the 20th items, and n you can see right there, and he's demonstrating that n is 2 to the 20th. And so this isn't just any array. This is a CU array. CU array in this case stands for CUDA array. CUDA is the programming platform for NVIDIA cards. And so we're targeting NVIDIA cards explicitly right here with the CUDA platform. So we have this array right here, and we're going to need another array because we're going to add them together. So now we're going to okay, so now we got 2 arrays, and we're going to try to add them together. I think what we're going to do is we're going to add them together. We're going to define the array to add them together, which is this is GPU add, and there's a couple things going on in here. One is we're getting like this block ID, we're getting a thread ID, we're getting block dimensions, we're getting grid dimensions, and basically all that is to say we're trying to set up the Can we get a font bump? Ryan, can you? Yes. Well, we're on Windows, so can we get a font bump? Who knows?
So maybe.
So maybe. Yeah, sorry for the tiny font.
That's a good question. What I might be able to do is stop the share and create a new share of only this, and then make it small enough that full screen.
Gorgeous.
Nice, yeah. Yeah. So here we have a for loop that we're iterating over the whole 2 to the 20th array, right? And we're adding the y element to the x element. So that's what we're doing here. There's a lot of like block index, thread index, and that's sort of to determine like what our our stride is gonna be. That's a little bit. It's I don't have my head quite wrapped around that.
So
but-
it's like if it's a for, x is your index, x plus equal the stride, and then x is less than or equal to length y.
Yeah. So let's try to add all these things together with the GPU add 3.
Yes.
Yeah, we have this sort of CUDA way of calling this, which is a little bit odd, and that's he's sort of mimicking the middle statement there, which is at CUDA, which is our that's a macro, right? So at CUDA, and then we're setting up the number of threads that we want, and we're setting up the number of blocks.
Well, first we need
that
to
we want.
need to define the number of blocks first.
Yeah. Because this thing is massively parallel, right? So not just, we're used to thinking in parallels in terms of cores, parallelization in terms of cores, but here we're going to be parallelizing with the number of threads and the number of blocks. And that ends up being a lot. Num blocks. Yeah, here we go.
And these are mutative, so so when we started out, YD was all ones, and now it's all twos.
Yeah. So a little bit underwhelming in terms of a demonstration, but that's sort of like the weird nuts and bolts of it. But we can benchmark this too. So I think we have a benchmark function in here that we have to define a function first, and then we're going to, it is already defined in our system, but that looks like this, where we're just basically doing what we just did, plus we're doing CUDA.atSync, because atSync sort of waits for all the parallelization to come back together again before it returns. Yeah, and let's do it. B time. That's our benchmark macro is called B time. We've got to do this weird money quoting thing because we're in a macro territory. And it has this super long pause right now. We do not know what's going on because it took only 99 microseconds. Right, so that's sort of that's the payoff right there, 99 microseconds. We copied a tutorial that was online, but the tutorial made clear that you could do this this particular exercise faster in the CPU actually. So, it's like instead of a blog in 15 minutes, hey, here we can build a blog in 5 days. Isn't this cool? But I think that really what they're demonstrating is, and what we're demonstrating right here, is the sort of mechanics for interfacing with your GPU, or if your GPU is a CUDA NVIDIA GPU.
Right.
So it's like a library. Someone wrote a library that ROPS, the CUDA
Yes.
driver?
Yes.
Okay, because when I was doing stuff with Python, I remember that like TensorFlow integrates with or has some integration with CUDA. So you're writing your stuff with the TensorFlow syntax, but under the hood, TensorFlow is converting everything to CUDA commands, whatever it is.
Yes.
So you don't have to know the CUDA API, right? So you need to know TensorFlow. That's the thing. So maybe like Julia, someone needs to come up with something, right? The ROPS CUDA for you, like a TensorFlow for Julia, or even if Julia can.
Yes, there's a specific there's a specific tensor library in CUDAs. I don't understand what tensors are, right? So, but there is a tensor. There's a CUDA tensor library, and I do believe that there's higher level abstractions as well to be able to interface with that.
Yeah, I think tensor is just like a multi-dimensional array. That's it. Just arrays of arrays. That's what they call it, tensor.
Gotcha.
Just
okay.
Matrices, yeah. But
yeah.
That's cool.
Yeah. I think that's it. Yeah. Thank you. Cool. So I think that we got Gabe up next.
Yep. I'm gonna share my entire screen. All right. Can you see it? So I'm gonna be talking about how can you reuse code between mobile and web. So as you all know, I've been building this app here for the past year and a half. It's a React Native app. So you have a bunch of, I already have like a bunch of screens, a bunch of user interactions. And I started, I guess maybe a year ago, I started building like an admin interface. So it's something that me and Thais, like we have to manage the admin stuff, right? Users, editing some workouts, importing data. So this admin web app started really small. So I just had like a list of, it was just like listing users, listing tracks. And I decided to bring the workout creation flow into the web app. So, and I already had that on the mobile app, right? So you could come here on the mobile app, click plus, and specify your workout name, workout one. You can create your intervals, interval distance like 1,000 meters. You rest like a minute, and then you click here, you duplicate again, then you have like 3 intervals, and then you save. And it displayed down here. And if I refresh the web app, now it's there. So I wanted to bring that flow to the admin, but I didn't want to rewrite everything, right? Like I was, okay, can I reuse the same thing, right? Can I bring my mobile React Native code to the web? And yes, you can do that. So there is a package called React Native Web. So any React Native component, like views, image, text, any of the React native components, you can render that in a web app. Of course, you have to be using React to do that, right? So if you add this library to your React app, this was like a create React app. I just added this dependency here, and I think I had to change some, I had to override some Webpack stuff for some of the libraries that I depend. But yeah, doing this, you are able to bring your React Native code into the web. So here, I had this button here, new workout. I click here, it displays the same almost the same UI as we see here. So I have the segmented control here, the same as there. I can click new interval. It displays the same thing. And so that's pretty cool, right? So I can bring stuff, but it's not like, it doesn't work like everything out of the box. Like, for example, this slider here, this was like a component that I was using from like another library, that when I ported this into the web, it wasn't working. So I don't know, it was like some weird, it was really slow. So it wasn't a component that I could fix, right? Because it was a library that I was using. So I decided to use another component on the web. So they look like almost the same, right? But it's like a different component just for the web. And you can clearly see, like when I hover on the web, I have this state, and on the mobile, you don't have that. So it's like a different component. So the way you can do that on React Native is like this. So I have a shared folder on my React Native app where all the code that's shared between web and mobile, I put on this folder. So the slider, for example, is that component that's shared between both, but they're different. They are a little different between the two platforms. So what I do is I have a slider TSX file that has some logic here, because my slider is not just a slider, it's a super slider, right? It does more stuff. It's a component that has like this label here. It could have this input text, and also the plus and minus on left and right. Oh, that was good. Live demo. It froze the the thing. But you can see here that like for this is the actual code that's the same for both platforms. But when it's time to render the slider, I have this component called Nativeslider. And this is the actual, all the props that I need to pass to the slider. And I have two files now. I have like a nativeslider.tsx and nativeslider.web.tsx. So nativeslider.tsx is just the slider that I used from that library, the React Native Elements library that was already present on the mobile app. And on the web, I use a different library. I use a Material UI library. So they have a slider component. And I just like returned the Material UI component. But I do some change on the props, because like Material UI, for example, the prop for the minimum value of the slider is called min, and the React Native one is minimum value, right? So I have to do some changes here on the props and on the on change as well. So this is how you can share components between web and mobile. Like I have a bunch of other stuff that I have here. So like a keyboard, scroll view. So for mobile, for example, when you are on the, if you have an input text, every time you have focus on the text, it shows the keyboard, right? And on the web, you don't have that, right? You don't have that. You can do it. You can type anything here, and there is no virtual keyboard. So one problem with with mobile apps is you have to focus the element, right? Like if you have a scrollable area, like for example, this one, interval notes, when I focus this, I want the keyboard to not be in front of the input, right? So I want the input to be visible. So this component here, keyboard scroll view, takes care of doing that for React Native. So it scrolls the scroll view if there is a focus on an input text. So in this case, for native, right, for React Native, so keyboard scroll view.native.tsx is my implementation using keyboard aware scroll view. It's a library that knows how to do this kind of focus on input fields. And for the web, it's this one. It's just the regular React Native scroll view. So React Native has this thing, this file name convention of overriding based on the platform. So if you want to override just for web, you put the name of the component .web. And if you, for example, if you want to override just for React Native, the name convention is .native. And there are other cases here. I don't know if I have it here. Like if you want for React Native to have a specific logic for Android or iOS, so you can have the same name convention. So for Android it would be .android, and for iOS would be .iOS. I think that's it.
Gabe,
That's really cool.
what is the mechanism by which you like that your compiler or whatever? I don't know how you compile this stuff if you're using Webpack or whatever, but it's obviously looking at the .web or the .native
Yes.
extensions.
So this config overrides here. Actually, no. Create React Native app. Create React app by default supports React Native Web.
Gotcha.
So So if you want to use React Native Web, it works out of the box. They added that to create React app. If you are not, then you have to do some Webpack configuration to add a loader based on that, on the file type and all that. But React Native does that by default, right? So React Native, it doesn't use Webpack. It use a different bundler, and it was built to do that because they needed to differentiate between iOS and Android, right? So they built that into the React Native bundler, and React Native doesn't look for the .web, right? So it doesn't care about the .web suffix.
Nice.
All right, that's it. Thanks, everyone.
Nice. So I think we're looking at Vinicius next, right?
Yeah. Hey, everyone. How are you doing? So Elixir was like the first language that I worked at, and it's still the first language that I work at that has for loop comprehension. And like the last week, I guess, I learned that the for loop comprehension could receive like a reduce option. So I would like to just like show this stuff to you. Let me share the screen. I wrote like a blog post about that because it was like super nice to share. So anyway, like I have like here an example of a list of structs. Let's say like people person structs with just like a flag to show like if it's active or not, a name and a surname, just like for interest here. So okay, so let me see. The for loop comprehension is that it seems to be like a regular for loop in the beginning. So if you want to iterate over that, let's say that we want to do this people, and then let me put like all in a single line. So here, I think that the first feature here is like to show the mapping, right? So I'm iterating over all the list of people, and I'm extracting the name, and I'm returning the name as like a list of people names. So this is like the first feature of this for loop comprehension, that we have the mapping. So the second thing is that we could also do like a pattern matching here if you want, and check that we want just the active ones. So like the behavior that Elixir has implemented is that if it matches, it will keep them. If it does not match, instead of like raising a match error that usually Elixir does on assignment operators, is that they will just like reject that from the value, right? We can also do the same filtering by not using pattern matching, but we can ask for questions like, is this active equals true? So these will have like the same results. So the difference here is that the first part of the for loop is like, it's called like generators. It has like this left arrow. And then the second part, I could put like another generator, or I could put like some question, something that it's gonna be evaluated, and if it's not falsy, it's gonna keep the values the same way as like the pattern matching, but this is focused to the truthness of the value, right? So the same like as active is like a boolean, I can just cut this equals true, and to have the same effect. So let me see the other example. Oh yeah, so I talked about generators. So another thing that I could do, I could use like multiple generators. So let's say that I want to just extract name from the first person, and I want to iterate over this stuff again. Oops. And I want to get the surname. And I want to show these as a string, as name and surname. So this, I think that this is like super awesome. Like it's not a feature that we usually use on daily work, but when we need to use this feature, is awesome to use. If you have to implement this, the same feature of doing this Cartesian product between all like, I get like all the names, all the surnames, and I have like all the combinations between name and surnames. If you have to do the same the same for loop in another language, like let's say like Ruby, would have like two nested for loops, and then I would have like two map and like flat to get like all results in a single map, in a single list. So I think it's awesome, like when I have to use this. What else I have it here? Oh, and here, this example, I have like two Johnny Smiths, because the first, on my first result here, I have like Johnny Smith and Robert Smith. So both like have like the surname of Smith. So when I do the Cartesian product, I have like two, I have like two Johnny Smiths, right, in the results. So one of the options that this for loop comprehension accepts as well is the unique true. So do just like cut the results. Another nice thing that the comprehension has is like the into. I think that this is like, it's like everyone that use like the enum knows about this. So let's say that we're gonna return like a tuple with like name and surname. If you call like the into all the, let me remove this into first. If you call this using the into, this will just like convert all the results to be like a map, right? And as it has like a bunch of like repetitive names, it will be just like converted to, it will basically like get like the last values of that. So that's why like it's Beth Jones, not Beth Smith or whatever. This is cool, but also the feature that I learned this week, and I have to grab this stuff real quick, is that we could also, let me clean this, we could also call like a reduce, and this is very similar. So what I'm doing here is that I'm iterating over like people. I'm calling like reduce to that. So the only thing that it changes, it's actually this syntax here. So we have like to put the act here. So it's gonna act as an anonymous function with like RT1. So inside this block here, we can access like person and act. So it will be the same as if you're calling like enum reduce with like two arguments, right? And then in this case, I'm getting the map here. I'm just like updating that. I'm updating on the key as the surname. And for this update is that the third argument here is that if there is no surname yet in the map, it's going to be just like an empty person list. Otherwise, it's just like an anonymous function, a shortcut, I guess, is that I'm going to, it's like a function that's going to return that's going to receive all the people assigned to that surname already as the one here, and then I'm prepending the person to that list, right? So that's why like Smith here has two people, two persons. So active Robert and Johnny. And that was like a nice feature, I guess. I'd like to share too because I like it so much to learn that. And that's all that I have for today.
That's cool. Thanks for the blog post.
Yeah, I think Elixir's comprehensions are one of the sweeter, most feature complete comprehensions.
Yeah, I've read that there's like Python and also in Haskell, right? So I never used this language, so I don't know how to compare, but it's
yeah,
quite
I've used
cool.
them in F# and Clojure. Clojure can probably do more. Clojure is crazy, but Elixir has a lot more features than like F# at least.
Yeah, I really like Elixir's comprehensions too.
As someone who doesn't write Elixir, that anonymous function at the end looked wild. Pretzel bracket person pipe pretzel 1 end bracket.
Yes. Like it takes a while because like, oh my God, it takes like a while, I guess, in the beginning to learn that, because you can always specify like what you're returning. So you can say that you're returning a list or you're returning like a string. It's super short, but it's nice.
I particularly liked using them to annoy Dorian, who didn't like clever condensed syntax. I will say that it is a bit you do have to be somewhat knowledgeable about the DSL. Like if you want to just use enum.filter, pipe into enum.map, that's probably a little bit more legible, but it's not as elite in my opinion.
It took me, Andrew, like having programmed a fair bit of Elixir, like it took me a little bit to unpack that as well. Like, but it's like, wait, that doesn't even look like Elixir. Oh yeah, okay, I think I see what it's doing. Yeah.
Yeah, I've done like a little bit, like very like simple stuff, but it's also been a while, so I don't like seeing like the shortcut stuff is like, whoa, that looks fancy.
Totally. All right. Well, I think Andrew, according to our internal show and tell Slack bot, you are next.
Yeah, for sure. So wanted to show off how I managed to find out all of the keys and secret IDs of all my Chinese HomeKit smart home devices, because the old way of doing it, or the old way I was using them with Homebridge, was like awful. There's like a few Homebridge plugins for using these Tuya branded smart home accessories with your Homebridge, but one of the old ones I was using was really awful, because what it would do is you would sign in with your Tuya account and then put this like in your Homebridge config, and when the accessory would show up on your phone and you'd hit like turn on, it would take like 5 seconds for the thing to turn on in your house, because what the plugin is doing is hitting Tuya's web API. So it's making like a round trip request to China and back just to turn on the lights in your living room, which is like, yeah, it's real weird. It's kind of a pain in the ass. I personally like to get home and hit the lights on. And so I'd like literally get home, turn on all the lights, and then sit there for like 5 or 10 seconds until they all like came back and turned on. It's awful. But this week I figured out a way to get around that by using a different plugin, but it requires some setup, and I'll show that off to you guys real quick, because I think Brian's in the same boat as me. Okay, so I'm going to share my Safari window. Okay.
Did you mention that? Sorry, the other plugin can work over the LAN, but to do that, you have to
Yeah.
have special credentials
Yeah.
to sign in to your devices.
Yeah, that's a good point, Brian. Yeah, so the alternative plugin I'm using will make the request over LAN, but you have to get the device IDs and secrets, which is something that Tuya makes like kind of hard to do. There was like an old way to do it where you would install some sketchy profile on your iPhone and then connect to the Wi-Fi that your device is on, and then it would packet sniff. Yeah, it would packet sniff and find out those values you need. Is super sketchy, and it didn't work either. Like I tried it, I sacrificed my iPhone to China. It didn't work. Now they have all my data. But anyways, so this is the new way to do it. So what you're gonna want to do is we're gonna go to iot.tuya.com. So if you have a Tuya account like through the app to manage their smart home devices, this is not the same. This is like literally like a developer account. So you have to create an account here and log in. And once you do that, you'll be greeted with this dashboard. And you'll want to come up here to cloud development. And over here on the right, there's a create button. So you just need to create a project here. It can be anything. So I'll just make one real quick. Cool. So I made my demo project here. And the next thing you'll need to do here is you need to link your demo project with your app account. It's just like really interesting way to think about things. You can actually like give your development account access to like random devices. Like Brian could give me access to his devices if he really wanted to. So you come over here to link device and go to link devices by app account. And what that's going to do is when you click add app account, it'll bring up a Tuya smart app QR code. And from here, you'll need to open the Tuya app and scan it. And you'll find that like under the settings in your profile. I also found out that this works with another app called, I think, Smart Home Connect. It's like also owned by Tuya, but not like explicitly labeled. It's pretty much the same exact application with like different branding. So once you do that, it'll list your device there. So I'll show you like what my actual one looks like just for reference. So this is my Homebridge project. Come down here to link device, link devices by app account. And here you can see this is my app account and I have one device under here under my linked project. So after you've done this, we need to go to API group here. So this is what opens up all your permissions to the development APIs. And I found out I had to apply all of them. It's really easy. You just click apply. Super secure process for vetting your reasons to use their API. You can literally write anything in here. Like it's not checked. Like you just fill in like, you know, fizz buzz and then like, yeah, it just opens your API access here. I love it. It's great. So once you've done that, we have access to the API. We have control access allowed for our linked devices. So you'll want to go to your device list. And now here's the part where we're going to get like I guess the keys and secret keys of all the devices on your network. So I'm going to look at my app account for America, and this is giving me like a identifier for my thing that I have on my network. So then what you'd have to do is I'm going to have to change my screen share to be my iTerm. You have to come over here and install this Tuya API, which is npm package. But you just do this npm I at Tuya API /CLI-G. And then we'll do this Tuya CLI-wizard. And from here, it'll either ask you to use credentials you've already entered, or it'll ask you to input new credentials. And the credentials that you would use here are under the project that you created. So I created demo projects, so I would use those here if I was setting up new smart home stuff, but I'm just going to use the ones that I've saved here. So then it'll ask you to provide this virtual ID, and that is that public identifier I just showed you guys in Safari. Cool. So then it gives us the ID and key, and these are needed to like turn the thing on and off on your network.
Oh man, now I'm gonna control your Christmas lights.
Yeah, well, you're gonna have to
Safari.
hacksaw my network first, so. But yeah, that's pretty much it, and that's a lot. It feels a lot better than you know, sniffing your network packets with some Chinese iOS profile. So yeah.
Nice.
How did you do the scan thing?
You have to go to your settings, your account settings,
Yeah.
and there should be an option to like scan a QR code.
Huh.
Here, let me look. I can tell you real quick. So yeah, so when there should be like a tab at the bottom that says me, and in the top right hand corner there's like a square brackety looking
Oh.
thing. Yeah, I don't know if you can.
Okay.
I can't see myself right now, but it's like
That's weird.
up there. Yeah.
Yeah, I got it. Thanks.
Okay, cool. And my terminal is like super broken because I just updated to Big Sur. But yeah, yeah, I know. Well, I don't do any development on my personal machine, so it's fine. Only breaking my home bridge once a week.
Cool.
Yeah, so.
Well, I look forward to more updates on your your IoT home life.
Yeah, we'll do.
Do we have any more show and tells out here? Candidates might be Matt Polito, Vidal Akachukwu, Brian Dunn.
I have very interesting Postgres stuff, but I didn't. I can't think of I'm trying to make like a fake schema so that we don't have to delete it all again, since I developed some of it in a client domain. So I didn't. I could use some brainstorming on that at some point, maybe, to build a fake schema for Postgres examples. But yeah, next week. Weird Postgres stuff.
I have some cool Postgres stuff too, but I think it's on client code, so I'll be considerate of that as well. I also have I built a curl wrapper in C++, but I also want to be considerate of everyone's time because it's 15 minutes over.
Yeah, it's well, I think people are just leaving when they're leaving, so as long as somebody's interested, it's cool.
I want to see your C++.
Yeah, I want to see it. Yeah.
It'll be quick.
I'm the only one that can't leave, so.
Yeah, we're sort of, that's true. We're sort of blocking Matt Polito from leaving. So maybe in the future we can set some more harder boundaries on this so that we're not trapping him.
there's a I think everyone here is familiar with curl, but I've been writing C++ lately, and you can access the curl that you see in the command line. I think it's a command line utility for the actual package called a libcurl that's written in C. And if you're writing a C program or C++ program, you can access that package directly and make curl requests with it. And the interface is weird and very C-like, but I built this wrapper to kind of help make it a little bit more intelligible. The way C works is that you have these header files where you declare all your members of your class and what you're going to ultimately define in the source file. And just to kind of help you walk through how it works, but this is how a constructor looks. If the name of the class is curl client, you have your constructor that'll take in a struct that I defined, and that struct will allow you to pass in body params, which is a map, which is C++'s version of a hash map or hash in Ruby and map in Elixir. Debug flags, some headers, the method, the HTTP method you're going to use, query params, and the URL. And then you can, there's this thing, the class or the type of the object that you have to use to do all your curl stuff is called curl. And there's what's called the easy interface for curl. So you initialize the curl object or pointer to the curl object, and then you start doing weird stuff with it. So like, let's say you want to prepare the request. That's the first thing that's going to happen in the initializer as I define it. And what prepare request will do is just set the body param, set debug, set headers, set the method, and then it'll execute it later. So if you skip down to the request, which is where it actually executes the curl request to the endpoint, it takes that curl object that you initialized at the beginning. It passes in this constant, this flag that's defined in the curl library called write function, which is how you have to tell it to write the response from the endpoint that you're hitting. It also you also have to define how there's an additional step that you have to do to write that response to an object or a struct of your choice, because this function has to be a static or a non-member function of your class. So it's just a little weird. Then you call curl easy perform to actually execute the request, and curl easy cleanup to clean up the object and all of its metadata that you've been storing inside of it. But it's little weird things. And how you set like headers, for instance, and the URL is you have to call curl easy set opt. On the curl object is the first argument, then you pass in the flag and then the value of that flag. So let's say you wanted to do header or to define a series of HTTP headers with there's this linked list that you have to define that's also in the curl domain called request headers. And you push to the back of that linked list with curl slist append the header string that you want to append to your header. And then you pass the pointer to that linked list.
See you, Marion.
To the curl instance that you've been accumulating. If you want to set the method, you have to do curl set opt HTTP get if you want it to be a get request, curl opt post if you want it to be a post. So it's just like this very involved and intricate way of just building upon this curl instance that you will upon which you'll eventually call easy perform, that will then kick off the request. And it just makes you appreciate things like just the curl interface in the client or in the terminal, and your Faradays or your HTTPs or your HTTP poison, or however you say that in these languages that do these HTTP requests. It's very fascinating for sure.
Vidal, what was your reason again for doing this? Why are you wrapping curl?
Did you just build curl on top of curl?
Yeah,
We're gonna call it Virl. VURL.
curl squared.
I mean, I
Virl.
guess you could learn a lot. That
Well, the
way.
reason is because I'm building for my stock trading app, I'm building a TD Ameritrade client, API client, and it needs to make HTTP requests to TD Ameritrade in C code. So I guess I could maybe like port out to the system and execute a command that is the full string of the curl request or something, and then just take the response and do whatever I want there. But I was like, I'll just build a curl wrapper.
Wait, is this thing in production?
It's on my GitHub. You can look at it. But no,
So this is like made to make like actual, like play with real money.
Yeah.
Oh man, you're living dangerously. This is like
Nah.
it's
He's
fine.
gonna. If
Put
anybody's
all
gonna
my
slay
money in Bitcoin.
This is a convenient function I wrote to take that curl object that I've been accumulating and modifying and print it into what we would understand as a curl request. Brian will recognize this because he did something very similar in TFS when we were trying to log the HTTP requests we were making to various APIs. Sometimes when you want to debug that, it's easier to just have your log output print what the curl request would be. So that's just a nice little convenience. But
He's done that on Venetti too. I'm sure that wouldn't shock you.
Yeah, when you pair with Brian, he finds ways to optimize log spelunking.
Yeah, man. We spend a lot of time reading walls of text, and if I get to choose what's on the wall, we're gonna make it cool.
But that's it. That's the gist of it. C++ has been a very fun ride. I feel like I'm learning a lot and feeling a lot. I'm learning a lot about programming that I wouldn't know or understand or take for granted with some of these higher level languages. So I'll keep sharing here and there as keep learning stuff.
This is
Yeah.
fascinating. So you said it's
Yeah.
a TD Ameritrade client. Why is it got to be in C++?
It doesn't. I could have in half the time written this in Ruby or Elixir. I'm just using this but because it would be just kind of trivial to do this, this feels like a good challenge to make me learn C++ by writing something that should be relatively simple to write.
He's a masochist. He
That's what I
enjoys
heard too.
pain.
It's like you would build like a Conway's Game of Life in F# or whatever language you're learning, Brian.
Sure, yeah. Cool, man.
That's it. Anybody else got anything to share?
Doesn't feel like it. Last week, Vidal, I sort of filled in for you for doing the outro, but it's you. It's you.
Okay, let me get my mic prop ready. You've just been shown and told live. Tune in next week for another show and or tell.
Woo.
See you guys.